So let's say you leave your cell phone at home so you can't be tracked. Maybe you grow a beard or wear sunglasses so that no one can see you, and you think no one can identify you. And then you go for a walk. Do you think you're anonymous in public? Well, think again. A revolutionary AI system called Watch can now track your exact movements in three-dimensional space using ordinary video footage. No special equipment needed. What's disturbing isn't that this MIT and Stanford creation can follow you around with unprecedented accuracy, but that it works with the same cameras that are already surrounding us every day: smartphones, security systems, and dash cams. While technology companies are going to celebrate this as a breakthrough for VR and filmmaking, they're conveniently ignoring the elephant in the room. Your unique movement patterns are becoming as identifiable as your fingerprints. I'm Evan Goldstein. I'm a licensed professional engineer and a data scientist. I'm building AI Capitalist to talk to the leaders and the thinkers like you about navigating this brave new world of thinking machines. When researchers at MIT and Stanford unveiled their latest AI system called Watch, which is a kitschy acronym for World-Aware Allied Trajectory and Pose Reconstruction for Camera and Human. That's interesting. They only used the W, the A. They skipped the pose reconstruction PR. So it should have been called WAPRCH. Anyway, they didn't create just another technical paper. They might have revolutionized how we can be tracked through video. Technology uses what's been a massive challenge in computer vision, accurately reconstructing human movement in three-dimensional space from ordinary videos. Previous systems were struggling with the fundamental problem of distinguishing between camera movement and human movement, but Watch is introducing a breakthrough approach. Researchers developed what they call analytical heading angle decomposition, which is a fancy way of saying that they figured out how to separate which way a person is facing from which way the camera is pointing. Now, this might sound technical, but the implications are enormous. So think about surveillance cameras in public spaces. With Watch, these systems could track not just where you appear in the frame, but precisely how you're moving through the physical world, even as the camera itself is also moving through the physical world. The system can reconstruct your entire body's position and movement with pinpoint accuracy. And what's more significant is that Watch works with ordinary monocular videos, i.e., it's like the kind that's captured by smartphones and dash cams or security cams with one camera, not three-dimensionally. No special equipment needed. All right, let's dig into what these guys did in a little more detail. Now, figure 2 here is like showing us what they did. The experiment was all about proving that their watch system could do something that other methods can't, which is to track the camera moving around and the person being filmed at the same time. The researchers set up their variables to compare camera poses and trajectories, which is shown in the top view, shown here, alongside human poses and trajectories in the bottom view. Then they connected it all to the actual video frames on the right. So they're solving something that I never really thought about before. When you watch a video of someone walking, your brain just assumes that that person is moving forward. But what if the camera was moving backward while the person stood still? The researchers created this dual perspective view to show that they can untangle that visual illusion and figure out who's actually moving where. Now in figure 3, this is getting a little nitty-gritty, but they're just creating a flowchart style diagram to show how information flows through their system like water through pipes. You've got the video images coming in on the left, they get processed through various components, and then everything is crunched together in their, what they call their rope transformer background, which sounds fancy, but it's really just a smart pattern matching system. So in figure 4, one of the tricks that they're using is G here, which I'll explain. This is actually kind of ingenious. Imagine you're holding your phone to record a video and you're walking around and rotating the phone in all sorts of ways. The challenge they're facing is how do you separate the phone's rotation from your actual movement? And the solution breaks rotation into 2 parts. It's like separating your head turning left-right from tilting up-down. And the G is representing gravity here, which always points down. And they use this as a reference point to figure out the orientation of the camera. It's like having a built-in compass that always knows which way is up, even when everything else is spinning around. Now, this is useful because if you think about it, when you're turning your screen, you know, when you have your camera or your phone, you're looking at the screen and you turn it and it automatically adjusts the orientation. That's because there's gyroscope inside of your camera that knows which way the camera's facing. And this is like another data point that can be used to suss out what the camera's looking at and which direction it's facing. Now, figure 5 is showing us the show don't tell moment that puts it all together. The comparison shows the same scene processed by several different systems and then watch their system at the end. And they're doing this side-by-side comparison because sometimes you need to see the failures to appreciate the successes. So if you look at these other models, they're not really accurately capturing the pose of the guy. The gray is mistakes or less accurate. And you can see the most blue, they really nailed the guy. They really got the pose right. And you can see in the failures of these other systems, there's a lot of poses that are just impossible. Like he can't be floating above the step here. Why is this relevant? Well, when I was living in the Holy Land, there's a lot of different ethnic groups living there. The two most common are Jews and Arabs. One thing I noticed just walking around was that if you put two people next to each other, you couldn't necessarily tell which was part of which group. And I'm sure if you've been to a foreign country, you've seen this as well. You would have the same complexion, similar facial features, etc. But you set the picture into motion, and you could instantly identify who was from which culture, because there are huge differences in body language and behaviors between the two groups. And this tracks down to the individual level. So your gait, your movements, your physical expressions, all of it can be used to uniquely identify you as a person. Now, think about what companies like Palantir are doing, where they're using drones, sort of drone footage of individuals walking around to identify whether a subject is Ukrainian or Russian, regardless of what uniform the person is. Well, now we can take this down to an individual level, and this technology, the watch system that these guys are developing, can watch you. So now, instead of a dedicated camera system designed to identify you, we could take footage from any camera anywhere and be able to locate you and where you are, even if you left your cell phone at home and you're covering your face. The privacy implications here are pretty profound. As this technology becomes more and more accessible, the ability to anonymously move through public spaces is obviously diminishing further. Your unique patterns, your gait, your posture, and your motion signatures are now trackable identifiers. They're biometric signatures. The researchers framed their work as addressing the long-standing challenge of camera translation integration and global human motion reconstruction. But what they've actually created is a system that can follow you through space with unprecedented accuracy using nothing more than ordinary video footage. The digital shadows that we cast may soon become much more detailed than we ever imagined. And if you're getting value from this episode, I would appreciate it if you'd push the like button. It really does help the channel grow. So what's the AI capitalist approach to this story? Well, the watch system represents a double-edged sword that businesses need to really carefully navigate. On the one hand, the technology does unlock enormous value across industries, from revolutionizing motion capture for game developers to enhancing security systems. And in my own industry of facilities management, we're going to be capturing the motions that people go through to do maintenance on various equipment types in order to be able to program robots to do that work. Now, for medium-sized businesses, this could democratize abilities that were previously only the tech giants were holding with massive R&D budgets. Looking at the long-term trajectory, we're seeing the continued erosion of physical anonymity. As motion tracking AI is proliferating across commercial and government applications, we're looking at a fundamental strategic question here. Do you position yourself as a privacy protector or a capability maximizer? The winners are going to be the companies that find the sweet spot. They're going to have to deploy just enough motion tracking intelligence to deliver the value that they need within specific operations, but also implement privacy safeguards. So what's your take? Is AI motion tracking like Watch the death knell for physical privacy in public spaces? Does it create an inescapable surveillance society? Or is this just the natural evolution of computer vision that's going to ultimately benefit us all because we're going to have better security, entertainment, and accessibility tools? The answer is probably somewhere in between, but let me know where you draw the line in the comments.